Okay. What's number 7 now?
7 and 9.
7 and 9. Okay, I'll do 7 and 9 before we go on. Okay, so in 7, the tree, yeah, okay, so I see here, you have battery, and then you have 1, 2, 3 resistors, but they say that each resistor is the same, so it's like X, and X, and this is 3 volts. So we can use the formula V equals I or. So you have, oh, and they also tell you the I is 0.5 amps. So you have V equals I or, and the or is 3x, because there's 3 of them. So you get X equals 2 ohms. Okay? Now, what they say next is what's the voltage? So what you do is you put a voltmeter on each of them. And they want to know the 3 voltages. So you can use the formula again, V equals I or. What's the I? It's 0.5. And what's the or? It's X. And what's X? 2. So 0.5 multiplied 2, that's 1. So this will be 1 volt, 1 volt, 1 volt. Yeah. Is that okay? Yeah. And then what do you say, number 9? Use the diagram to the right to answer. Okay, how much current would be measured in each circuit if each light bulb was 6 ohms? Okay. Can I go down? Yeah. So here is 6, and then here is 1, which is 6 ohms, and then here this is 6 ohms. Okay. And they would like the current, so you can have V equals I or, so I equals V over or, which would be 6 over 12, which is 0.5 amps. Then in the second picture you have 2 batteries. So the only difference is that the total is 12 volts now. So when you use the same formula, I equals V over or, it will be 12 over 12, so it will be 1 amp. How much current will be measured in each circuit if each light bulb had a resistance of 12? Yeah, so then for the next example, what they do is they change these to 12. So it's the same thing again, you just change here. What would this be now? What's this here? 24. It'd be 24 instead. It's the only difference. Yeah, that's all really. Okay, so these are Ohm's law. This is okay then? Yeah, no problems? Okay. So we'll go on. So okay. Now, in fact, the resistors we've had so far have been put together like this. One resistor, and then a second resistor like this. And this is the same as one big resistor, R1, yeah, plus R2. That's what we have so far. But it is a little bit different when they are parallel. So for example, if you have them like this, one here, R1, and then another one here, R2, and then your battery here. Yeah. Now, the resistance here is not R1 plus R2, because what's different about this circuit is it's parallel. Okay? Some important things I should say first before I talk more about this. This here has voltage V. Okay? Are you looking? Yes? This has voltage V. Here and here both have voltage V as well. But current, so this is current I, this is current I. What happens here is the I splits. So you have some I this way and some of the I goes this way. They're not necessarily the same. So your voltage stays the same when it splits, but your current doesn't stay the same when it splits. So if this was a 6-volt battery, then there's 6 and 6 in these two. And if this was a 2 amp current, we don't know. Maybe it's 1 amp, maybe it's 1 amp. Or maybe it's 1.5 and 0.5. We don't know. They split though. But there is a way to work out the total resistance. We can combine these together. When you have this situation, you can use this formula for total resistance. In fact, 1 over R equals 1 over R1 plus 1 over R2. So this is how the resistance combines when the resistors are parallel. Let's have a look at an example. Can I go down? Yeah. So let's take this one here. We have 12 volts. And we have one battery. We have another battery. Oh, sorry, not battery, resistor. And this is 2 ohms, and this one here is 2 ohms. So what you can do is you can say that that's the same as this, with one resistor, like that, with OR. And we need to work out the OR. So we can say 1 over OR equals 1 over 2 plus 1 over 2, which is 1. So then OR equals 1. So this is 1 ohm. Now if I use V equals IOR, well actually what am I looking for? Yeah, okay, no, that's fine. So what I want to get is the I. So then the I equals V over OR, which is 12 over 1, which is 12. Okay, so here is 12 amps. Is that okay? Yeah. Now what I want to do next is I want to get the the current in each of these. What's the current? So what formula could I use? Well, I could use V equals IOR. So then what does I equal? I equals V over OR. So what's the voltage here? 12. And what's the resistance? 2, so what's the I? 6. So this would be 6 amps. And this one here is 6 amps. But what did we say the total should be? It's 12. So what's happening with the amps is you had 12 amps, and then when it hits this here, it splits 6 amps in the first one and 6 amps in the second. And the reason it's the same is actually because they're both the same resistors.
So they will always half and half.
Not always. It's only the half and half here, Louise, because they're both 2. That's why it's half and half. But if this was like 3, and this was like 4, or whatever, they will be different. I'll do another example where it's different. Yes. We'll do one where it's different. How did I get to 6?
Yeah.
It was 12 divided by 2. Yeah. Okay, can I go down? We'll do another one. So, I can go down? Yep. So let's say here we have our battery. We'll make it 10 volts. And then we have one resistor. Then we have another resistor. And let's make this one 2 ohms and 1 ohm. Okay, so what's the total resistance? It'll be 1 over 2 plus 1 over 1. So then 1 over R equals 3 over 2. So R is 2 over 3. So V equals IR. I equals V over R. So that's 10 over 2 over 3. So that's 15 amps. So in total we have 15 amps. And here going back is 15 amps. But we split the current in these two places. So again, we can have I equals V over R. What's the voltage here? 10. And what's the R? 2. So this is 5 amps. And then here, it's 10 divided by 1, which is 10 amps. So what happened here was your 15 was split into 5 amps and 10 amps. Okay. Right, is that example okay for you, yeah? Okay. Now, just the other thing to say. Can I show them? You have, what do I want to do in the next one? Yes, yeah. Okay, so there's a special type of circuit I want to look at, like this. You have your battery with voltage V, and then you have R1, and then we have R2. So as you know, the voltage here, I'll say V1, and then the voltage here, V2, they're going to be different, but the total should still be V. Okay, So let's work out what it is. We can say V equals I or. And V equals I or. But we need to work out the I. So we have V equals I total resistance. So that means I equals V over total resistance. That equals V multiplied 1 over R. But what does 1 over R equal? Well, we just had that rule a moment ago. It's 1 over R1 plus 1 over R2. So I have my I know that I equals V 1 over R1 plus 1 over R2. So if I take this and put it back in here and here, I get V1 equals I, which is here, multiply R1. So you get R1 multiply 1 over R1 plus 1 over R2 times V. And then V2 equals R2 1 over R1 plus 1 over R2 times V. Oh no, I did something so stupid, sorry. Oh man, sorry, I just realized I did something really stupid. Can anyone tell me what stupid thing I did? I did something stupid. Here, this is wrong. This is wrong. Because these are not in parallel. The total resistance is just R1 plus R2. So I just need to change this here, sorry. It is 1 over R1 plus R2. So I just changed these here. 1 over R1 plus R2. Over R1 plus R2. So our answer is V1 is R1 over R1 plus R2 times V, and V2 is R2 over R1 plus R2 times V. So I'll give you an example. Can I go down? Yeah. Not yet? No. Okay. Can you go down? So for example, here, if you have 10 volts, and this here is 2 ohms, and this here is 1 ohm, we'll say, then the voltage here, that's V1, that is 2 over 2 plus 1 multiplied 10, which is 6.66 volts. And then here, the voltage V2, that is 1 over 2 plus 1 times 10, which is 3.33 volts. this type of problem, this type of circuit, this is called a potential divider, because what it does is it takes your 10 volts and it splits it into a 6.66 and a 3.33 volts. Why might you need to split your voltage? Why do you think you would want to do something like this? Well, give me an example, specific. Say again, Oh yeah, that's one light, so you could have bright lights, dark lights. Yeah, that's one. And an example I was thinking of is like your computer here. So this power supply, do you know what the voltage is here? 240 volts. And what is it back in Hong Kong? Is it 120 or 240? Do you know? Might be the same. Yeah, so UK is 240. And Abraham, what is it back home for you? 240 or 120? 240. Don't know. Okay. Is it? Some of my Saudi students told me they have 120 and 240 at home. In Lebanon it's 120. Oh, okay. 240 in Kuwait. Anyway, this here is 240. But then if you think about your computer doesn't need 240. Okay, maybe the screen needs 240. But I think this part here, the processor, would only need maybe 12 volts. Okay? So what I'm saying is, this is how you can split your voltage. So for example, if you have 10 volts, you could make 6 volts here and 3 volts here, because different machines need different voltages, okay? So that light needs 240, that would need 240. But something like the calculator, that calculator only needs 1.5 volts. Yeah. What did we say the phone was? It was 3.5. Was it 3.5 or something? Wasn't it like that? Yeah. My phone is 3.7 volts. Different machines need different voltages. This is one way you can split voltage, if you need to split. So it's called a potential divider, okay? And text message. Because get 50% free credit. I don't buy much credit anyways. Okay. So what I'll do is I'll let you try some of these parallel circuits for a few minutes, and if you get them finished, there's a couple more, 2 more, which are a little bit more difficult. But there's only 4 questions here, and it really should only take you maybe 5 or 10 minutes, because you can see they're not very long. Okay, so if we can do this for a few minutes, and when we're finished, we'll go to the next lesson then. In fact, I didn't do the first one. What was my first example? Was it 10 volts? Yeah, okay, this one's different. Alright, so if we try those 4 questions. So the important word here is parallel. That's what you call this situation. Parallel.